Hey folks, this hopefully quick video is on the types of acceleration you might see in AP Physics 1. Now that we know about centripetal acceleration, I wanted to take some time to lay out everything. So types of acceleration, we're going to start with the one that we learned about at the beginning of the year, linear. So we studied linear motion, and linear motion is all in a straight line. So motion in a straight line can include acceleration. If the velocity is changing, then there is acceleration. The acceleration is in the same direction as the change in velocity. So if an object is moving forward and speeding up, then their velocity is getting more and more positive, and their acceleration is positive. And this can happen in any dimension, x, y, or z. This can include projectiles. For a projectile, acceleration in the x direction is 0, but acceleration in the y direction is equal to negative g, or negative 9.81. So linear acceleration does not have to mean that the object itself is moving in a straight line, but it just means that the acceleration can be directed in one of the axes, or sometimes two at a time. So it might be two-dimensional. To give a two-dimensional example, if you are in a boat and you are just leaving the dock, then maybe the boat's acceleration due to its motor is going to be in that direction. But maybe the wind is blowing, and so there is some acceleration in this direction. If you have like a crosswind, then you have an acceleration that is directed perpendicular to the boat's acceleration. So in this case, there's two linear accelerations, and then the overall acceleration of the boat would be in this direction, due to the vector nature of acceleration. So, you would feel the boat's acceleration forward, you would feel the wind accelerating the boat sideways, but really overall you would just feel the boat being pushed in this direction. So linear acceleration is in our like x, y, or z direction. We also now know about centripetal, and that just means towards the center of a circle. Toward center of a circle. So if we have an object that is moving in a circular path and it's right there, then it has, it has a centripetal acceleration in that direction. When the object is down here, its centripetal acceleration is directed that way. Centripetal acceleration is kind of always changing direction, but it is always pointed toward the same thing, and that's the center of the circle. We have the magnitude of that acceleration here, the speed squared divided by the distance from the center of the circle. When we are in the UCM portion of this, it means that there is a constant centripetal acceleration. All right, so again, we can update that later once we have non-uniform circular motion, but that's what we have so far. All right, now there's one more to talk about, and that is tangential. This has to do with things that are moving along a curved path. So it's the same equation as linear. Truthfully, all acceleration is the same equation as linear. It's just that the way that it plays out with centripetal, we get a special equation that comes out of it, v squared over r. We will deal more with tangential acceleration in our rotation unit, but again, it's the same idea as linear, but it has motion along a curved path. So it's linear acceleration, but the line it traces is actually a curve. The acceleration is always tangent to the curve. So this is what sets it apart from regular linear acceleration. If I go back to this example, this object we've been assuming is moving at a constant velocity or constant speed around this circle. If it wasn't, it would have a tangential acceleration. Tangential acceleration would look like this. It would be in this direction. You would call it AT for tangential. And so this is for something that is accelerating not only around in a circle, but it's accelerating forward. And so that's the tangential acceleration. These two are related. Increasing if you have tangential acceleration, that means that the speed of this object is increasing, and this equation tells us that means the centripetal acceleration is also changing. And so this centripetal is what we focus on now. Tangential, we'll see that later in the course, but I want you to be aware of it, that you can accelerate in that direction. And then it's not a type of acceleration, but you can have the net or total acceleration, which you actually saw up here. And when we say the net acceleration or the total acceleration, it is the vector sum of two or more acceleration values. And so this happens a lot in sports. When you like swing anything or go to hit something, your arm or leg is involved in two different categories of acceleration. So I'm going to attempt to draw this and talk about a soccer kick. So we're going to put a soccer ball on the ground, and then we're going to make a rather large foot to kick it. There we go. And so the ball is going to go like that way, but we're going to focus on the acceleration of your foot. So basically, like when you go to kick a soccer ball, when you bring your foot back, your foot is temporarily at rest. So your body has to accelerate your foot forward. And because your leg is attached to your hip is also pulling, the muscles in your leg are also pulling upward. So it's not necessarily a perfect circle. Like your foot might not make a perfect circle. It might, I actually don't know. But we have like two types of motion that are happening. When the foot actually makes contact with the ball, the following things are happening. There is a tangential acceleration of your foot in the direction where the ball is, because your foot is speeding up as it gets to the ball. And then again, because your foot is attached to your leg is pulling upward on the foot. And so there's two types of acceleration. This happens again in like baseball swings, baseball throws, tennis serves and shots, basically anything where you're swinging something or throwing something. You generally have two types of acceleration, one that is kind of like pushing the thing forward, and the other one that's pulling it. And that actually is going to increase the overall acceleration of that system, because we have a vector sum that's going to be pointed along a hypotenuse that you'll see in a minute. So we can make a triangle out of this. We can say the tangential acceleration is directed that way. We can say the centripetal acceleration is directed that way. And then this hypotenuse is now the net acceleration at some angle. And that's going to help, any athlete is going to gain more velocity to their body part or the bat they're swinging or the ball they're throwing because of the multiple accelerations that are happening. And so that Pythagorean theorem is going to govern what the magnitude of that is, and you have two types of acceleration feeding into one of it. That's all for that. I'm not going to do practice problems with this yet. I'm just going to make you aware of it and then move on. Thank you.